Directional drilling sensors, the basics. Today we're going to cover a quick summary of how directional sensors work and the differences between them. This is a conventional instrument, 15-year-old technology possibly, but still used every day. Very good sensors. What you have with the directional sensors, you have the accelerometers at one end of the tool. Ignoring that end, that's just a transmission package. And then the magnetometers at the other end. Why is that? Why do we have these four circuit boards in between those two sensors? The reason is that we want to isolate the magnetic sensors from the gravity channels, or the accelerometers as we earlier called them. Most conventional tools behave the same way. They'll have four circuit boards between those two sensor packages, and that's all very good except for one thing. One of the problems with that is the alignment is absolutely critical between the accelerometers and the magnetometers. So what happens when you have four different boards? Two issues. First of all, you have all these connectors in there that have to interconnect, so a lot of areas for possible failures. The second thing is the torsion. You can actually twist and modify the alignment just by hand of these. So in the old days, that was the best electronics could do. It was four boards, and this is a MicroTesla tool. This is a 10-steer probe, one of the newest 10-steer tools, high res, both of them. Both suffer from the same issues. And then MicroTesla, about 3 years, maybe 4 years ago now, came out with a one-board tool. They dramatically improved the circuitry, made it one board. So you get a solid chassis all around with the exception of the little wire channel. You get a very rigid chassis. You just don't get that misalignment anymore. This is an NDS, used a lot in the oil field, a drop-in replacement for a lot of the old legacy tools out there, but much higher quality. Then came the NDM. The NDM differs from the NDS in that it's smart technology. It has the one board design, as you can imagine. It has the accelerometers on one end, can't get away with that. The magnetometers on the other end, and then the transmission channel of wires. Again, one circuit board, so very, very rigid chassis. The improvement of this one over this one is basically the ability to interface with so many different more sensors, such as gamma ray sensors, pressure sensors, inclination at bit. Anything you want to add to it, you can add to this one. As well as the other benefit of this one is the ability to calculate inclination and azimuth while rotating. This is used in the HDD industry and wireless tools, and will hopefully be soon offered in a wired package as well. So that basically concludes the basics of sensors and why the one board tool is an absolute game changer in accuracy, reduces the requirement for calibration to near, well, let's just say near zero. Very rarely do you need to calibrate an instrument like this. And that's it, folks. That's all.